Hello, this is now part 2. In this video, I'd like to discuss now how to do this problem by solver. But before that, let me have a review. You see, the problem is we have chocolate candies, and we would like to know how many candies or how many pieces of product A, it's called more choco, and classic choco, 5S. And we know that these are generating 6SR and 5SR, given this recipe and these limitations. So these are constraints. We cannot go beyond 5 kilograms of milk, and we cannot go beyond 12 kilograms of milk. This is our mathematical formula or algebraic formula on solving this particular problem. So if you notice, I'd like to just repeat the equation. The profitability of A is 6SR per piece. Profitability of B is 5SR per piece. And so you have total profit of A, total profit from B. So you have a total profit overall. And this is the milk supply, the limitation. And this is the requirement. 1 kilogram per piece for A, for milk, 1 kilogram of milk for B, 3 kilograms per piece for chocolate, and 2 kilograms per piece for choco. 2 chocolates for product. This is product A and product B would require milk. And that's 1, and for chocolate, for chocolate required, product A and product B, 3 and 2. All right, 3 and 2, correct. So this is my solution, since I don't, at that time in video A, I do not know yet solver, but I know how to use spreadsheet. So I guessed it. I made a guess subject to the limitation like this. Then I am now beginning to study solver optimization. So I form this equation, and let me now form that equation again for your for understanding it. First of all, the point that we have to do is to take note of the decision required. The decision required is how many kilograms. So what is the quantity? Quantity for product A. For product A, how much should this be? How much should this be? And how much should be the quantity of product B? That is the decision required. So I'm going to put that into a color. So let's say it's yellow, to highlight it, and put a like this. Furthermore, so those are the required decisions. So that's B86, B86, and C86. Let me write down, just for to help our memory here, the cells. So that's B86 and C86. These are the two very important cells. So cells, cell location, cell references. Now, then we have to take note now of the profit that we get. These are the profitability, the profit from A and from B. For one piece of product A, profit from product A and profit from product B. And what is that? product A and product B, how much is the profit? It is 6 SR for product A, isn't it? 6 SR per piece, and this is 5 SR. Since this is like constant, this is never changing, I'm going to color them by a different color, light green maybe. Yeah, like this. But still, I'm going to put them into a border. Oh, what happened? And put them into a border. Right. So here would be the total profit. How do you do the total profit then? Total profit is what? You multiply the B86 times what? B89. What is B89? This one is B89 plus C86 times C89. So you can see here that if, for example, you have one quantity of product A and one quantity of product B, your profit is 11. So now I'm going to highlight that again. And this one would be a result. So it's not a I put them in orange. These are a result of a computation. So I'll put them as 0 here again. So we want this to be maximized, because it is also in later on you will learn that we can also do a minimum. We want the cheapest, but now we want this maximized because it is a profit. And then the requirement now. So the requirements is that there are 2 requirements. You can write here all the requirements. One is milk, one would be chocolate, isn't it? So for milk, we know that for one quantity of product A would require 1 and 1. I think that one is here. 1 and 1. So 1 and 1. So the required total required milk, total requirements for this for milk is what? You have to multiply only this to this. That's why I wrote it here. It is a very important reference cell. So we'll do like this: B86 times B93. 93 being this one. Okay, and plus C86 times C93. And so this is the required milk. Must not go beyond but what is the supply? I mean, what is in the maximum? What's the upper limit? Upper limit of this? How many kilogram of milk? It's 5, isn't it? Are you still there? 5. So 5 kg. So since this is constant, Same with this. This is constant. I'm going to color this with green. I'll put green here. Anything constant, anything part of the questions. Also, this one are constant. You don't change them. So 1 kilogram for product A, and for product B. 1 kilogram for one piece. 1 kilogram for one piece. You multiply that by this. So if I put 1 and 1, will now be 2 required. Correct? And this is the upper limit. Upper constraint. And just to highlight this, I'm going to do bold. And you know, the relationship is what? Less than or equal to. Less than or equal. Isn't it? Or let's use the symbol less than or equal to. Are we still okay? And the next would be the chocolate. The chocolate would be what? The chocolate would be 3 kilogram for product A and 2 kilogram for product B. 3 and 2. And so here, the requirement therefore would be equals B86 times B94 plus C86 times C94, and this is also colored green. And what's the upper limit for this? The milk, upper limit for milk. For choco, what's the upper limit for choco? It is 12 kilogram. You know, you can make this smaller. This is what? 6 kilograms, isn't it? Or 12. And I'm going to color this with green as well. If you notice now, class, these 5 and 12, these are the upper limit. This is the required. And in the same manner that these are calculated as a result of calculation, I am also going to color this as an orange to remind ourselves that these 12 are requirement. If you notice also, this is the decision variable. That's why sometimes we call it decision support system. They help you make a decision, and this is the thing that you would like to maximize. This part, and maybe we should put it in a different border. Why it became taller? I'm going to remove the yeah. Okay, so it's 11. No need for 00. I like this. Decimal 0. So again, let us see. If we put in I'm going to write here what we made a decision on here. 1 and 4, isn't it? we put 1 and 4. Let's see if 26 will come out. 1 and 4, the result is 26 over here. If I put in 1 and 4, 1 and 4, so it's 26. Where is the orange line? All right. But the point is, now I would like to use Excel now. Before we move on, let me just review with you. This is B89, and this is like this. Look at the equation. I'd like to introduce to you here one method of writing this. This is a sum product of this B86 up to C86, comma, and then B94 up to C94. That's it. So it has the same effect as this. It has the same effect as that one. So I'm not going to rewrite this, just so to remind you that they are the same. And therefore you can also change this without writing. You can say, because this is the more appropriate way. Sum product of B86 up to C86, comma, and then B89 up to C89. Why is this necessary? Because there are cases when you have like 100 products, and sometimes you have requirements of 200 requirements of ingredients. Under that particular formulation, once you are able to identify the vector, the area that are multiplying, all you have to do is to write down the first point and the last point, and put them this semicolon. Then you can have the equation. One more testing. Suppose we say it is 1 and 2. Do we have 16? 1 and 2. 1 and 2. There you are. So right now we have laid out our LP, our linear programming model. This is called a model. This is now called a model to solve the problem. How do we solve this problem is based, you can do this in a more like tabular format, but in our case we use Excel to solve this. How do we go and solve this? That's the third part of this video. But first you must have this laid down. Okay, so lay it down. So basically the approach is, I'm going to remove this. The approach is understand the problem. Step 1, understand the problem. Then identify the relationship together with the variables. Number 3, lay out the model. Once you are able to do the layout, so this is the laying out the model layout. Then you now start using Solver of Excel. The third video will go towards this step number 4.